This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 3, Lesson 5, Absorption Refrigeration. This is the chiller that runs on heat instead of shaft work. A generator, an absorber, and a small pump stand in for the compressor, so the machine can be driven by steam, hot water, or exhaust. The catch is a low COP, around 0.8. We'll build the 3-temperature model, then work a single effect COP and its minimum generator temperature. Concept 1. What absorption is. A normal chiller pays a compressor to move refrigerant. An absorption chiller pays with heat and carries the refrigerant in a liquid solution. The compressor is replaced by an absorber, a small pump, and a generator. The reward is that it runs on waste heat. The cost is a COP near 0.8, far below vapor compression. Concept 2. The 3-temperature view. Heat enters at a hot reservoir, the generator. Heat leaves at a mid-reservoir where the machine rejects, and heat is drawn in at a cold reservoir, the evaporator. Energy balance says the 3 heats sum to 0. The entropy balance is greater than or equal to 0, with equality for the ideal cycle. Set entropy generation to 0, and you get the ideal forward COP, cooling over driving heat, as a product of 2 temperature ratios. Concept 3. The single effect layout. Refrigerant is boiled out of solution in the generator, condenses, drops through a restrictor to the low pressure side, evaporates to do the cooling, and is reabsorbed. Mapping the reservoirs. Hot heat is generator heat, cold heat is evaporator heat, and to a good approximation, the evaporator matches the condenser, and the generator matches the absorber. Setup. The single effect relations, all from one page. 1. The ideal COP is bounded by a product of 3 temperature ratios. 2. A practical estimate is 1.2 times evaporator times condenser over generator times absorber, which lands near 0.8. 3. Lift is condenser minus evaporator, drop is generator minus absorber. 4. The minimum generator temperature is condenser plus absorber minus evaporator. Setup. A worked machine. A single-effect lithium bromide chiller. Generator at 200, condenser at 105, absorber at 95, evaporator at 40 degrees Fahrenheit. Add 460 to each for absolute degrees Rankine. Convert first. Temperature ratios mean nothing on the Fahrenheit scale. Solve. The first ratio is 105 over 660, about 0.16. The second, 500 over 65, about 7.7. The third, 565 over 555, about 1.02. Multiply, and the ideal COP is bounded near 1.25. The minimum generator temperature is condenser plus absorber minus evaporator. 620 Rankine, 160 Fahrenheit. And our 200-degree generator clears it, so the machine runs. Remember, the bound is optimistic. A real single-effect chiller delivers about 0.8. Traps. 5 ways this bites. 1. Use absolute temperatures everywhere. Add 460 to Fahrenheit first. 2. The COP is about 0.8, not 3+. Don't compare it to a vapor compression number as if they mean the same thing. 3. The inequality chain is an upper bound. The 1.2 form and the 0.8 typical are the real values. 4. Below the minimum generator temperature, the cycle stalls. Nothing boils off. 5. Heat drives it, not work. Only the small pump takes shaft work, so COP is defined on the driving heat. Quick recall. The 3-reservoir balance gives energy and entropy laws, and the forward COP has 2 temperature ratios. Map the reservoirs onto the generator, condenser, absorber, and evaporator, and you get the single-effect COP chain, the lift, the drop, and the minimum generator temperature. Golden rule. Absolute temperatures always, and a COP near 0.8. The heat buys the cooling, and the pump is almost free. Next up, Lesson 6, Refrigerants, Properties, Selection, and Safety Classes. We'll read the Handbook safety table, the A and B toxicity split at 400 parts per million, and the 1, 2, 2L, and 3 flammability classes, with the examples you need to recognize, like R22 as A1 and ammonia as a B2. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.